One minute further here. So today's topic is a system on chip. So we are going to discuss about the routing algorithm. So my name is Anita Rani. System is AEC department excellent in knowledge. So what is routing algorithm? A set of rules or procedures followed by the network devices to determine their optimal path for data packets to reach their destination. So consider we are going to consider various factors here like conjunction, distance, bandwidth, etc. to inform if the routing decisions is correct or not. So it plays a crucial role in the network performance and efficiency. For example, if you are going to imagine one complex maze, automatically a routing algorithm is like a map or and a compass for data packets navigating these maze. It analyzes various factors like traffic, different paths, available bandwidth, and distance to the destination. Choose whether it is an efficient route or not. By making their intelligent routing decisions, these algorithms ensure data reaches its extended reception quickly and reliably. There are two types of routing algorithm. It has been categorized into two. One is distance vector routing, another one is called as linked state routing. So we are going to see about the distance routing, so which is the shortest path we can easily. So distance vector routing is the type of routing vector routing protocol used in networks to determine the best path for the data packets to reach their destination. It works by the routers exchanging information about neighbor routers and their distance to other destinations. So we are going to find out the shortest path and we are going to analyze how it works. It depends upon the routing tables, routing decisions, and the distance calculation. Routing tables, each router maintains a routing table containing information about the reachable destinations and the number of hops required to reach them. This table is based on the information received from the neighboring routers. The information exchanges will be periodically sent to their routing tables to their directly connected neighbors. This exchange of information allows routers to build a picture of network from their perspective. So distance calculation will be calculated depending upon the number of hoops between their router and the destination. However, some protocols might be considered other factors which will be delay as well as or bandwidth. Routing decision. Routing decision is nothing but it's based on the information of the routing table, and the routers choose their next home with their least distance. There is a shortest distance for their particular destination. The data packet is then forwarded to their neighbor router, which makes its own routing decision based on its routing table. So advantages of this distance vector routing, it is very simple to implement because its setup is very minimal processing powers on routers. It will be scalable for small networks. This works under smaller networks where number of routers will be very limited. Disadvantages is that has slow convergence, routing loops, limited scalability. Here, for example, if any one of the loop has been failure, it can take time to for the routing tables to update across their networks. So leading of your temporary routing loops is in the insufficient paths is not. So routing loops means it's used to prevent the complexity. So protocols will include mechanism to prevent loops, but they can add complexity in the system. Limited scalability. So it has grows larger and more complex. The number of routing updates can become overwhelming, impacting performance. So next, first when we have studied about the distance routing vector. So there we have a very small network. So next one is linked state routing. So in this linked state routing is very powerful and efficient routing protocol used in their computer networks. Unlike the distance vector is not focusing on their hoops count, extending hoops count. Here it is more comprehensive approaches to the network navigation. So it can share link information sharing and network topology map in a shortest path calculation. There we have least count. So here is also the same one. A link information sharing means each router in their network shares information about their state of its directly connected links with all other routers. This information typically includes the cost, which is bandwidth, delay, etc., associated with each link. Network topology map is nothing but it represents the entire network as a graph and which routers are nodes and their links are connections between them. Shortest path calculation. So we are going to use a powerful algorithm, the DGS algorithm. That is, routers can calculate the shortest path and according to the destiny in the network. So this calculation considers the cost of each link away along the way. So this is the diagram, block diagram. We have A, B up to C, D, F, G, H, I. So a starting point is A and ending point is I. So depending upon the shortest path of that has been mentioned here. So you need to choose your destination. So shortest path can be find it out according to the destination. For example, if I am moving from A to F, A to F means we can move to a, B, D, E, F or A, C, F. So you can calculate the shortest path here. So 4 plus 8 is 12, 14, then 20 to reach the A to F. Another way of shortest path is A to C, C to F directly. So that path will be 8 plus 1 will be 9. So which is the shortest path you can easily identify. From that routing updates you can finally fill out. So if this is the easiest method, you can easily find the destination of the path. If you want to have I, so we can choose which is the simplest path of it. So you can calculate accordingly. So advantages of this link state routing is nothing but fast convergence and looping free routing scalability. Fast convergence means when that there is change in the network, all routers have a complete network map and can quickly recalculate their shortest path. This leads to their fastest conversion, that is compared with their distance vector routing. This will be very fastest. And loop free network is nothing but we can avoid routing loops because each router has a complete view of their network topology. And scalability is nothing but we can handle larger or more complex networks due to sufficient information sharing and path calculation mechanism. So when you are going to compare your distance vector, there will be very smaller unit. So this can be used as a larger unit. So this is advantages over a distance vector routing. Disadvantages increasing processing power. So they need the routers to maintain their complete network map and perform complex path calculation. Requires more processing power and memory compared to their distance vector routing. So bandwidth overhead. So it is a frequent exchange of link state information can consume more bandwidth, especially in larger networks.